Hi everyone, welcome back. In this video, we are gonna focus into these member functions, these parameters of this GFTT detector. Actually, in the previous video, we simply just talked about what GFTT detector is, also how we can initialize the class. Actually, this was the example from the previous video. Different than the previous one, I just added some parameters so we can see the default parameters of these member functions. And also, if we run, if people directly watching this video, basically we just did example, and here I used a simple image because my target is to explain you what this class is doing, also the purpose of the parameters we can understand clearly. And here we already discussed there are some noise detections. Our target was detecting the features, which is also corners we can say. And here there are some noises also, is because if we zoom we see some corners here. So according to these details, in some cases this detection, this backend is calculating some noises, but we can filter them out, and in this video we are gonna do that. Also we are gonna get the correct corners of this simple image. Okay, and here, as I said, I added some console out because we can see the default parameters of these member functions. If we go into here, we simply just see get maximum features, get quality level, and just get minimum distance, and get block size, also get gradient size kind of. And this Harris detector actually basically I don't want to get into the details of this. According to this, since also we are dealing with a simple image, this Harris detector, if you make it true, it's gonna use the Harris detector in behind. Also, if you make it false, it's gonna use something, if I'm not wrong, Thomas is something like that, the algorithm is gonna use. So for Harris detector, I already have a video in my YouTube channel, you can check it out. But the most important parameters, we are gonna get into the details of these parameters, okay, which I already put in here. So this get max features is given as 1000. This is representing the backend is gonna only give you output the number of the feature output. For example, in here 1000, it can give you the corners, the detected corners until 1000. If you make it, just after this we can make it in here setting, just set maximum features, let's say 3. Now we are expecting it's only gonna give us 3 features, 3 corners. Let's see now. Oh, let's make it a little bigger. You see 1, 2 and 3. There are only 3 points as output because we changed the maximum features parameter. This is simple, this is easy to understand. So this is filtering the output of the features. Also this is of course gonna give you an efficiency. For example, in your cases, if you only need, let's say, 5 corners we need to detect, I don't know the case, but let's imagine in that case, if you make it 5, it's gonna be efficient, I can say. So this is important in those cases. And this quality level, actually if we remove this and run, this is actually we can think like quality. For example, now if we are increasing this quality threshold, quality level is gonna ignore, I think, this filter. We can do that. So the defaultly in here we see 0.01. Let's make it little increase. Let's say detector dot set quality level, let's say 0.8, which is meaning give me the perfect features, perfect corners. Let's see. It says these are the only perfect ones, 1, 2, 3, 4, 5, around 5. So it's not able to detect these or these star corners. So it means we gave really high threshold. Let's make it 5, how it looks like. And I have still corners which the backend is not giving to me. So let's decrease more. Let's make it 3 maybe. Now I still miss one more here. Let's decrease one more time, 0.2. Okay, now I got all the corners in my image. So this is important. You need to in some cases you need to decide your threshold level by experience, as I did now. So for my cases 0.2 is a good number, good quality level. So this is basically threshold you can remember as. Okay. And the next is minimum distance. This is also easy to understand from the name also. Detector is defaultly 1, which is even the detecting one. For example, here there is a corner. If there is one more corner, just 1 pixel beside it, it's gonna also detect that. So it's the threshold, the distance is really low. For example, let's talk about here. You can check the coordinates here. I'm always reminding you. The pixel around the x-axis is 132, and here the x-axis 172. So around 40 pixel between these. So I believe if I make it 45, just by setting detector dot set minimum distance, let's say 45, my expectation now is gonna be removed. Okay, you see this is removed. So between them is there's a hypotenuse, so it's around maybe 60. So but these are removed because if they are close to each other, lower than 45, it's filtered, so they are removed. If you little increase more, let's say maybe 80, many of them also will be removed. For example, these are also removed now accordingly. So this minimum distance also was important. And the next is block size. Actually this is you can remember as median blur kind of things. So it's in the behind, just making some blurring kind of thing. So just if you increase it, maybe the default is 3, let's make it 33. Maybe you can get some weird results as we did now, you see. So since you see this picture, but in the behind, since it's making some operations according to your block size, so it's giving some wrong results as output. Also we get some dummy number, which is 33. But if your image is, if the corners are not easy to detect, or they are some, even if the output is close to the result, maybe you can use this option also. But 3 is gonna be working fine for most of the cases, I believe. I think, yeah, this video, I think I just wanted to talk about the member functions and the parameters of this GFTT detector. Now we are able to detect our features, our corners, and I'm done for this video. Thanks for watching. See you in the next videos.